Welcome to Pomodoro Joe for Thursday, September 14th, 2023. Today we're doing LeetCode problem 332, Reconstruct Itinerary. This is a hard problem. Come on, man. 2 hard problems in the middle of the week? LeetCode, you're killing me. All right, you're given a list of airline tickets, where tickets at index I is from and to. All right, we have a destination and our source city. Represent the departure and arrival airports of one flight. Reconstruct the itinerary in order and return it. All of the tickets belong to a man who departs from JFK. Thus, the itinerary must begin with JFK. If there are multiple valid itineraries, you should return the itinerary that has the smallest lexical order when read as a single string. All right, so that means alphabetical order. For example, the itinerary JFK LGA has a smaller lexical order than JFK LGB. All right. You may assume all the tickets form at least one valid itinerary, and you must use all the tickets once and only once. Oh man, this is tough. Then we have some examples. So we're given these cities. We can go from Muk to Lübeck, and we can go from Jufk to Muk. So you go from Jufk to Muk, and then from Muk to Lucher, and then from Lucher to Suf, and then to Sujuk. Okay, let's put 25 minutes on the Pomodoro timer and see if we can do this one. All right, let's start with a result. Our result will be an empty list, and we'll return our result at the end. All right, first up, let's create some kind of graph, because we know we're at certain cities. I mean, you can see from the picture, it looks like a graph. So we can go from some cities to other cities. So let's just create a graph that maps the, departure city to the destination cities. Okay, so let's call that, what do I call it? A flight map? No, we'll call it a connection map, or connection map. And this will be a default dictionary of lists. So the key will be our current city, or the departure city, and the value will be all the cities that we can reach from this departure city. Let's make a note of what this is here. All right, so then we have to go through every city. So let's see, we can have, I'll call it source and dest, SRC. DST. So that's the source city and the destination city for each ticket in our tickets. So the connection map from this source city, we can just add our destination city, or append. Cool. So now we've gone through, we've got all of our source cities, or the city that we can fly from, map to all the cities that we can fly to from that city. This could be it, although we might need to do something with this lexical order. I'll have to think about that one. We might want to sort these cities. Actually, we probably do. Yes, we do. Let's sort these cities. So the reason I'm sorting these cities is because we want to prioritize the smaller valued cities, or the cities with the lower lexical order, the lower alphabetical order. So let's sort these cities. So for every key or source in our connection map, for this source, we'll just sort. Okay, so we've got our map of all of our sources to all our destination cities, and now we need to start somewhere. So we'll have a stack. We're going to be doing like a depth first search for this. So we'll have a stack. This is going to be our city, and we're going to start at JFK. All right, now while we have our stack, so while we still have some cities left to travel to, we will see where can we go to from this city. So I'll just call this the source, or maybe I'll call it city, current city. What do I call it? Yeah, I'll call it current city. So my current city is stack at -1. Now I'm not going to pop it out of the stack because I think I'll be using these, I'll be building up my stack as we go, and then I'll pop them later. All right, so my current city is the last city on the stack. This is where I'm currently at. So in the beginning, I'm currently at JFK. Now, where can I go to from this city? So let's just check. If, is our city guaranteed to have destinations? It's not. We might end up with something like this SJC here, where we can't actually go anywhere. So this key won't be in our dictionary. So I better make sure. If our current city is in our mapping here, our connection map. So do we have connections we can go to? And our connection map for this current city is not empty, so we still have something there. Then let's go to the first city in our map. Yeah, sure, why not? So we'll go to the first city on our list, which will actually be the lexically smallest city, which is awesome. So let's see, I'm gonna grab a city out of the list. So first city, or maybe I'll call it destination. Yeah, I'll call it destination. And that will just be this connection map for our current city. I'm actually gonna pop it out. So I'll pop, and since I'm pulling it from the front, I'll pop at index 0. All right, so I'm gonna grab my destination city. Now I'm gonna travel to that city by pushing it onto my stack. Stack.append this destination city. Maybe I'll forget the city. Yeah, it's okay. Yeah, I'm actually gonna change this to just DST. It's a little bit easier to read, I think. There we go. I might change this to just current. No, I'll leave it current city. Okay, so we'll check. Do we have any other cities we can get to from our current city? If we can, if we do have these connections, then we'll just grab that first connection I can get that has the smallest lexical value, and I'll put that on my stack. We're going to that city. Next, we'll go to the city, we'll keep going. At some point, we'll run into the end. We don't have any more cities that we can get to from this current city. So if we get to that point, we are done traveling for this leg of our journey, and we'll actually have to put this current city onto our itinerary. We've reached the end point. So let's see, we'll actually grab our itinerary, which is our result, and we will append this current city. And at this point, I do want to remove this current city from my stack. So I have to do stack.pop, and this one will be at the end of the list. So this will be at -1. Cool. I think this might be it. Now there's one thing. So this result is actually in the wrong ordering. So essentially what we're doing, we're starting out with our starting city, push it on the stack. Then we just say, where can we get to from this city? We're not moving it, we're not taking this off the stack, we're just gonna check, where can we get to from this city? So if we have destinations we can get to, we'll try each one of those destinations. We're going to actually remove that destination from our list, we'll push it onto the stack. Then when we loop around here, our current city becomes that destination city. We'll see where can we get to from there. So we keep going down this list until we've exhausted all of our destination cities. We get to some endpoint. At that endpoint, we will then put that city, our current city, onto our itinerary because we've run out of places we can go. Okay, and then at the very end, we'll have our result. Now our result, since we put the last city on first, and then we popped things off, and as we sort of popped back up our chain, we put our last city or our first city on last. We actually do need to reverse our result. So we can do it just by doing that. Okay, I am not sure this is gonna work, but let's give it a shot. Hey, what do you know? That works. Let's run this whole thing and see if we can pass all the tests. and we pass. We don't do great, but we pass, which is better than I thought we'd do. We beat 45% for runtime and 99% for memory. Wow, we do great memory. So let's jump back here and see what we can do. A couple things we could do to make this perhaps a little bit faster. Instead of using our standard stack, we could use a deck. Let's see if that helps. But when we use a deck, that does mean, let's see, that we can still pop. But this won't be a pop at -1, it'll just be a regular pop. Deck still works, and wow, that's a huge improvement. Now we're at 97% for runtime and 95% for memory. Wow, using the deck saved the day. Holy smokes. Cool. Well, I'm going to leave it there then. I'm pretty happy with that. So for this one, again, we went through, we had to build up our list of connections from our source city to all of our destination cities. Then we went through and we sorted all those destination cities so that we would have the lowest lexical order first. So that means we could go through our sort of lower alphabetical ordered cities first, which means as soon as we found a result, we already know it's the best result. All right, then we start our stack with our JFK, that's our initial airport. Then we'll just go through for every city that we can get to from our last city, our current city. We'll put that on the stack. Once we get to the end, we can't go to any more cities. We'll then put our final city onto our result. Then we'll move back up our stack when we get to that final city. So it's kind of like, you can think of this as branches. It's a tree that's branching. We go down to the very end branches. Then as we come back to a node, we figured out all the best answer from that node down. We're going to have to put that node onto our stack. And that node is this destination airport, or this airport at the end of our stack. All right, and then we keep going until we pop all the way back up to our very last or very first airport. We put that into our result, which means that our result is reversed from what we really want. So we have to reverse our result before we return it. Okay, that's it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.